All right, thank you so much for joining us. I'm going to ask Dennis to introduce himself, and then I'll introduce myself.
Yes, hi everybody. My name is Dennis Kamatsky. I'm a principal software engineer at Corning. I've been part of Corning since 2020. I'm focused on ML engineering and advanced analytics. I'm part of Corning IT, digital delivery, value acceleration. And my personal interest is in natural language processing and information retrieval.
Yeah, hey, Pulkit Chadha. I'm with Databricks. I'm a solutions architect. Have been with Databricks for 3 years. I'm also the author of data engineering with Databricks. How many data engineers or self-identified data engineers in the room? All right, that's fine. And how many ML engineers, ML ops? All right, yeah, right. You're in the right room. I do have a bunch of giveaways that Dennis is going to give away. I have a bunch of copies out here, so stay till the end. I don't know what Dennis is going to throw at you from a criteria perspective, but there'll be a giveaway. All right, so from an agenda perspective, for the next 40 minutes, what we're going to do is I'm going to give you a Mosaic AI overview. It's going to be super high level. I'm just setting the stage, kind of bringing us all together so that we are speaking the same language. I'll then hand it over to Dennis, who's going to do most of the talking. He's going to talk about Corning. He's going to talk about GenAI at Corning. He's going to talk about GenAI on Databricks at Corning. And then we'll end with what the future direction of the platform is and some of the features, sneak peek into the features in the future. All right, so starting off, Mosaic AI. How many of you have seen an architecture of Mosaic AI, know what Mosaic AI is? All right, so that's about 2% of the room. Okay, so I only have 2 slides on this. Again, super high level. Any of our Mosaic AI sessions, you'll be able to get deeper into each of these topics. But I don't want to take a lot of time away from Dennis. So real quick, when you talk about Mosaic AI and GenAI in general, there are 3 kind of architectural patterns. You can call them use cases that we support, starting off with like just prompt engineering at first, right? So just using an existing LLM, doing prompt engineering, using a foundation model. All you're doing is prompt templates, right? Just basic stuff. Then the second pattern here is what I call like customizing your LLM with data, and there are different kind of themes at it. How many of you know what RAG is? Okay, all of you know what RAG is. All right, so the first thing is RAG. I won't explain what RAG is. The second is a little more advanced, where you're fine-tuning a foundation model with your own data. The third pattern here is what we're seeing with customers is fine-tuning and RAG together to improve accuracy. And then the final pattern is pre-training, where you have billions and trillions of like data points to just build your own LLM from scratch. So those are the 3 patterns that we support on Mosaic AI. What we'll be covering and what Dennis is going to talk about is mostly in the RAG space. And then we'll talk, are you going to talk about like fine-tuning a little bit? Okay, awesome, that's fine. So RAG is where we are at today, this session. If you want something else other than RAGs, get out. All right, so now double-clicking, and this is my second slide out of 2, just digging deeper into mapping the RAG architecture and mapping it to the features that you have available on Databricks. And I divide this into 2 sections. The first is prep, and the other is like serving, right? So starting off with, you ingest a bunch of documents, and these documents can be in table form and in UC volumes. How many of you use UC volumes? Only a few of you. Okay, so UC volumes, basically just a cloud storage location. You just drop files in there, and you can auto-trigger workflows based on the file arrival. Once the files are over there, you do some prep, ETL traditionally within notebooks, within pipelines from Hugging Face, or just regular old Spark. You're chunking, you're cleansing, all of the goodness that comes with unstructured data prep, right? The third step is you're loading a embedding model, either from a UC managed model or from the marketplace or a Hugging Face model. Either one works. You're taking that embedding model, running GPU compute, computing the embeddings in the notebook, right, and saving those embeddings into a a data serving layer. And this can be either a open source library, vector search, which is our capability, which is our managed kind of vector search capability, and then you can also use third-party point solutions. And Dennis is going to talk about the differences between what the considerations should be. Once you have the embedding saved, this is the good part, right? You choose a second model, which is your actual LLM kind of model that is being served. And this is model serving. And the real cool thing about model serving is what we call like unified serving. And the idea behind this is regardless of what model you choose, if it's a foundation model, it's OpenAI or any of the other services, or an external model, all of them get an abstraction layer on top of them called model serving, right? So anything you choose, the same interface applies. So what that means for you guys is as you evolve, your APIs stay the same, your downstream systems stay the same, and you have like standards downstream, right? Okay, so now there's an AI app, and there are different versions of the AI app. For Corning, Dennis, you use like a web app, right? You use a web app where you can serve a model with notebooks, you can serve a model as SQL functions. And again, I'm just encapsulating all of the various kind of deployments all at once into this one block. The user queries the application, again, in multiple interfaces. The query is turned into embeddings. This is the retrieval part of the R. You guys know about this. So you take the query, search for the similar documents from the vector DB, construct the prompt, embed or augment, this is the A, augment the prompt with the similar documents, send the prompt to the model serving API, and then the model serving API, what it does in the platform is there's this component for model monitoring. We call it lakehouse monitoring. And the idea here is you log all of the responses and the requests that the endpoint is getting into inference tables, which are delta tables. So they're capturing the ground truth data for like further fine-tuning downstream. And then finally, the response is sent back to the user. Everything's great. This loop keeps on going through. You're capturing the logs behind the scenes. You're making sure that your models you're served in a unified manner. And then behind the scenes, you can use any model that you want on Databricks. So with that, it's Dennis time.
All right, thank you. Good. Good afternoon. So today we're going to talk about how we used some of that in practice. This is all very new, so we used some of these components in real life. First about my company, Corning. Corning is a glass and ceramics manufacturing company. It has almost 175 years of experience with material science. It's headquartered in a small town called Corning, New York. If you're ever visiting the Northeast, I highly recommend going to Corning, New York, at least to see the Corning Museum of Glass, because you'll see 3,000-year-old glass artifacts as well as modern glass products, and you'll learn about glass manufacturing process. You'll learn about how to draw optical fiber, how to build fusion glass for iPhone screens and stuff like that. It's fascinating. Corning is a global company. It has manufacturing facilities in all over the world, from East Asia to Europe to North America, and it makes a lot of products. We group them in 5 major categories. So like I said, anybody who has an iPhone is using Corning glass in iPhone screen. It's Gorilla Glass, scratch resistant, tough glass. If you had a COVID vaccine, most likely it came in a Corning vial made by our pharmaceutical division. Optical communications is very important for Corning, so making fiber optic cables, and that powers internet, powers hyperscale data centers that are very important for generative AI, as you know. And then if you're driving a car, your catalytic converter probably uses Corning mesh ceramic substrate, or an air particulate filter also uses Corning ceramic substrates. So today we're going to talk about generative AI applications. And before we dive into technical details, I just want to introduce what a generative AI application is, right? Because everybody's talking about LLMs and which one's better. Is it Claude? Is it GPT? But at the same time, some people don't realize that what we already expect from generative AI cannot be done by the model itself, right? So if you have a conversation with ChatGPT, you kind of expect that it has a memory of what was said before and uses that memory as a context for your conversation, for the next answer. You expect to be able to upload a file and then ask questions about the file. LLM itself cannot do those things. LLM is stateless. It's, from engineering perspective, it's a string input, string output function. So you need another component which will orchestrate information flows between enterprise systems, the user, and LLM to provide this enriched functionality. And this is what I call generative AI applications. So we build and deploy these generative AI applications on Databricks. So we had a number of hackathons in Corning. We talked to product teams. We had reviewed a lot of, like a long tail of ideas, very creative ideas about how to apply generative AI in manufacturing. But at the same time, when we look at this distribution of ideas, the head of it, the vast majority of ideas and the need is with RAG. So there's, it's either talk to your documents, talk to my company documents, or talk to my company data systems, SQL databases, data APIs. So from the point of view, so Pulkit covered RAG very well, and I want to take a look at RAG from the point of view of how independent the decisions that LLM can make are from the application, right? So if you think about classic RAG, you have an application that will receive a question and run it against a retrieval system. So the retrieval step is essentially hard-coded, right? And a retrieval system, by the way, doesn't have to be a vector database, right? It can be like a classic inverted index with TF-IDF scoring, or your enterprise search API, or like even a SQL query based on some filters provided by the customer. But you can also imagine, going one step to the right, that your LLM decides what query to run against your system. So you don't hard code the query, LLM decides. LLM can construct a SQL query, right? So that's a text to SQL that's very popular in setting up use cases for talking to the data. Then you can take it one step even further. And that's where agents come into picture, right? So this is where your LLM not only decides what query to run, but also decides which systems to query. So you do it by creating a component called an agent, giving it tools. Tools have descriptions. LLM reads the descriptions of those tools, and then makes a decision which tool should the agent use on behalf of the LLM to retrieve the information. Then the agent retrieves it, provides it to the LLM as an observation, and then LLM generates the response to the question based on the observation. So if we look at these applications and we think what they actually are at a high level architecturally, they are essentially conversational interfaces to enterprise data. And if we were to go ahead and build a classic interface to enterprise data, like an enterprise portal, right? We would first have to go and talk to our enterprise architect. And the enterprise architect would have a conversation with us about non-functional requirements, right? We know what business wants, but the architect wants to talk about latency, throughput, observability, maintainability, operational support, all those things. So for a company like Corning, which deals a lot with proprietary research and intellectual property, NFRs regarding data security and data governance are the most important. And so just like the enterprise portal would have to authenticate the user and authorize that user for every data record, we have to implement the same thing over the conversation. But LLM is part of the design, and LLM is inherently stochastic, right? So you cannot predict what it will generate. And if you give it some tools, you cannot predict what tools it will use and in what sequence and what inputs it will provide to the tools. So this becomes a challenge to implement data governance on top of this. In addition, there's new types of data that we have to govern, right? So there's vector database, there's conversation history digests. Even the LLM prompts may contain company information, very proprietary, very restricted. So our journey, looking at all these NFRs, talking to the business about what they need. Of course, the first approach that you consider is, okay, so let's look at LLMs. What are they from engineering perspective? They look like an API, right? So like an OpenAI API. And there's a lot of experiences, decades of experience building API integration applications, right? So we can build it that way and deploy it to the cloud. And any junior engineer can do it. However, when we consider these NFRs about data security, data governance, we realize that using existing data platform to build and deploy these applications is the way to go. And Databricks Unity Catalog natively integrates with MLflow, Databricks Vector Search, Databricks Model Serving, and Data Lake. And so that allows us to manage the source data and the generated data byproduct of generative AI in a consistent and harmonious way. Of course, we also have to consider which LLM to use. We cannot use public API like OpenAI, right? So we can use an on-prem deployment. We are also using Databricks foundation models like DBRX. Some of them are great. But for us, what works best is our enterprise Azure OpenAI account, which gives us access to GPT-4 models, which is state of the art, and they work best with complex prompts like agent-based applications. So the next question is how to build the code. To be useful, generative AI application must make multiple calls. Like I said, it has to be an orchestrator. And orchestrating information flow once is easy. You can just hard code everything. Twice, 3 times over, 5 times around, it's hard. It's hard to keep that code from getting out of control. So you need a framework. So luckily, open source community came up with generative AI application frameworks that capture best practices for building and organizing these information flows and also include some very useful prompts. These chain frameworks are now revolutionizing GenAI application development in the same way that I remember inversion of control frameworks like Spring revolutionized web development 20 years ago. So we settled on LangChain, which is the most popular framework with the largest development community, and also it is supported natively in MLflow with the MLflow LangChain model flavor. And that framework was also selected by the Databricks RAG Studio team, which is now called Agent Framework. But I am told that Agent Framework will provide support for Llama Index in the future as well. So with Unity Catalog, MLflow, LangChain, we are using Databricks-centric architecture for building GenAI apps. We package our applications as MLflow models. And that includes all our proprietary Corning built code as Python wheels stored as MLflow artifacts in the models. And we deploy these models to Databricks serving as REST APIs, which are then integrating with Corning proprietary front ends in the cloud and on-prem. We use Databricks vector search for unstructured retrieval and Databricks SQL warehouse for structured retrieval. So some examples of use cases which we implemented. US patent search. So we ingested a year worth of patents and patent applications from the public USPTO API. This resulted in over 25 million embedded chunks. And of course, Databricks vector search was critical for being able to search this amount of data. The other use cases have less data, so it's internal proprietary Corning documents, but they come in a variety of formats, Word documents, PDF files, PowerPoint presentations. So it's interesting use case to be able to extract information and index from those documents. Other set of use cases are talk to the data use cases. So I want to be able to have a conversation with my data lake table, right? So I have a Power BI dashboard showing me some data from a gold table. I want to be able to have a conversational interface to the same table. Databricks has a great solution for this called Genie Data Rooms, and we're definitely using that and exploring that. At the same time, we're also building agent-based applications to generate SQL queries. And as we built our experience with these types of applications using structured chat agent component from LangChain, we also realized that this approach is useful even for unstructured document RAG. Because think about patent search, for example. A user can send a generic query about multiple patents, or a user might ask something about a specific patent by patent number or patent title, like give me claims or give me abstract from this patent. So you need two different tools for this agent. One tool searches the database, and another tool looks up patent by ID and provides that specific patent to the LLM. Luckily, Databricks vector search has filtering functionality. Hybrid search works really great. So we were able to implement both kinds of tools using the same underlying technology. Lessons learned. First, talking about document ingestion. Definitely use Databricks data engineering best practices. And to use them, read this book by Pocket. Medallion architecture, very useful. We found that for extracting content from diverse document formats, unstructured, that's the name, unstructured library is great, it works great. One thing about it is that it wants to send your documents to an API, and definitely if you use proprietary data, restricted data, do not use the APIs. Run unstructured on GPU, on Databricks managed GPU infrastructure. Works great, speeds up the data pipeline. Then after you extracted the content, you chunk it, you vectorize it. There's models which can vectorize your documents or embed your documents through an API. So you grab a piece of text, you send it to an API, you get a vector back. That is expensive and that is rate limited. So it's cheaper and faster to run embedding locally on GPUs. So to embed 25 million documents, we definitely had to build parallel vectorization process running on multiple GPUs. One important thing, keep track of the size of your embedding model's context window, right? So what they will do is they will take a chunk, and if the chunk is longer than the embedding window, they will just trim it and give you a partial embedding, and that ruins your search results. So make sure that they're in sync. Keep track of a Hugging Face leaderboard to see which embedding model works best for retrieval as of today, but also keep in mind the number of weights. Number of weights in the model translates into how long it takes to produce an embedding. We actually had a concern that, hey, we can vectorize on GPU at index time, but at query time, at inference time, we need to run on CPU, otherwise it's too expensive. Will it be too slow? It's not. Majority of time at inference is still spent in LLM generating that LLM answer. So we had to build our own kind of a LangChain component, LangChain vector store, to connect to Databricks vector search, because LangChain was not ready with its own component back then. Today, there is a Databricks vector store implementation in the LangChain community. It's available. However, its indexing pipeline is very naive. It's just sequentially vectorizing and indexing documents. We had to implement kind of a multi-stage, parallel, multiple GPU embedding, and then parallel upload through direct index access API to Databricks. And our Databricks team had to pre-scale the indexing infrastructure because we were overwhelming it with our indexing requests. So luckily, you don't have to worry about this today. There is a Delta sync where you can pre-generate your embeddings, store them in a Delta table, and then tell Databricks to sync a vector index with that Delta table with the pre-generated embedding column. Application packaging. So our key idea is to deploy generative AI application APIs similar to generic large language model APIs, so that to the API consumer, it looks and feels like it's a model fine-tuned on Corning data without the actual fine-tuning. So deploying these APIs requires first packaging the software and then shipping the package to a runtime environment. So for example, in the world of containers, right, your Docker image is your package and your Docker container is your runtime environment. So what we found is that MLflow registry works well as a packaging mechanism for our code, and Databricks model serving works well as a runtime environment for our code. It was, so from lessons learned, it was very helpful to pre-download all dependencies. There are going to be hundreds of jars, right? Like especially if you run, Hugging Face embedding model. Pre-download them and pre-package them with this MLflow model as MLflow artifacts. That speeds up the deployment of serving endpoint. So application development. Generative AI applications are interactive by nature, and they require interactive development experience, especially when you're doing prompt engineering, when you're doing agent engineering. You need to interact with it a lot when you're developing. So we found Databricks notebooks to be perfect fit for such interactive AI development experience, especially with the agent framework. There's MLflow tracing UI, which runs directly inside of your notebook. So it's kind of a similar experience to Langsmith. At the same time, we have to follow MLOps best practices from Databricks, right? So deploy code, not models. So transition code between environments, not models. So we support that through Corning built MLOps toolset, which allows us to inject job metadata directly into the code of Python notebooks. And then our continuous delivery pipelines discover that metadata and run notebooks to package and deploy generative AI applications in the environments where a data scientist or a developer doesn't even have access to the UI, to the notebook UI. So quick example, building a very simple bot I had to remove a lot of like Corning specific keywords. That's why I have a lot of asterisks. But you install a generative AI framework library, right, which has everything I talked about. You supply some metadata for the production deployment in the first cell of the notebook. You read some documents, grab some texts, create or download a embedding model from Hugging Face. This is a very small embedding model, good for testing. You vectorize the documents and index them in an embedded in-memory vector database from Meta. Create a LangChain retriever that will retrieve 10 best results. Create an adapter to LLM API, in our case, API managed GPT in Azure. Create a conversational retrieval chain with the hard-coded flow, right? So this is not an agent example. Log it to MLflow registry, create a new version of the model in MLflow registry with the updated code. And finally, test that you can load the model from MLflow using PyFunc flavor, because that's the flavor that it will use. So when you log a model with LangChain flavor, it also adds a PyFunc flavor. And then in serving, it will use PyFunc flavor to load the code. So test that you can load it and then deploy. Future direction based on our challenges. We definitely had some difficulty developing our code at the same time when MLflow and Databricks and LangChain, all of them are evolving at the same time. So we need to, I think I'll just go to the next steps because it's there. So we need to kind of converge to the latest and greatest GA release of Agent Framework. That would be highly recommended. And we also need to rationalize how we manage our production deployments, managing our tokens, managing our Unity catalog permissions in a systematic way. But I would say our vision involves automation, automation, automation. So we need to improve automation of all operations. We need to provide self-service data acquisition to the business users. That's the top thing that they're asking for. At the same time, we kind of need to give business analysts some autonomy in prompt engineering and helping ML engineers develop GenAI applications. Because a lot of times, prompt engineering is only possible with the help of a business expert in a particular line of business. So ideally, they would have some kind of user interface that would help them prompt engineer, and then their prompts would automatically flow into new version of application through automation, right? And so we need to evaluate the models and also give business analysts ability to provide feedback on a GenAI application. And we need to flow the results of that evaluation back into automation so that evaluation helps deploy or checkpoint the deployment of the new improved version of the GenAI application. And now back to Palki. Thank you.
All right. Yeah, so thanks, Dennis. You heard Dennis talk about a lot of the features that Dennis and team have leveraged on Databricks. They got access to a lot of private preview features that are now GA. And then we've also worked with Dennis and the Corning team to identify some of the product gaps, some of the seams that are a little rough around the edges. And that's what I wanted to cover next. This product name is not fixed. That's why it's in square brackets. Like naming things in tech is always difficult, right? So they haven't named this, but they are calling it Agent Framework as of right now. Have you guys heard of Agent Framework? RAG Studio? Okay, yeah, two of these, yeah, three or four. Okay, all right. So The idea is aligned with the future direction that Dennis ended with, is the fact that, hey, it is getting difficult to manage the end-to-end life cycle of a agent framework-based application, right? From a Databricks perspective, there's LangChain, there's so many different tools, there's so many different moving parts. How do we bring that into a operational model that is more prescriptive than before, right? So again, I'm just going to give you a sneak peek. If you get a chance to go to Eric Peters' session, I think it's tomorrow. I don't remember the time. It's Advanced RAG. The title has Advanced RAG. Do sign up for that. It's full, but if you line up, he'll go deep into all of these features. So starting off with, you saw that Corning had to do a lot of work in productionizing the application, right? There are a lot of things outside of Databricks that we have to solve for, things within the Databricks that are difficult to solve for. The pain is trying to figure out, like, how do you judge the model outputs, right? How do you evaluate those models? How do you have that closed loop from a DevOps perspective to iterate on the model before you deem it production ready, right? So that's the problem that Agent Framework is trying to solve for. And again, this is just a overview of, like, what are the steps you need to follow from a RAG application development perspective, and then where, like, RAG Studio or Agent Framework, I'm sorry, I was going to do it once. It used to be called RAG Studio. Fits into all of this, right? So again, just real quick, running out of time, but I want to give you some time for questions. Again, RAG Studio allows you to make sure, Agent Framework allows you to make sure that your quality of the model is managed, right? You're able to rapidly develop, like iterate on the development lifecycle. And then all of that is governed in terms of figuring out if there's user input, like if they're giving you a thumbs up or down for, like, responses and so forth, right? So there are 3 benefits. So now, I promised 2 giveaways. So first giveaway, if you want to share this code, there's a 25% off on my book. 25 data engineering discount code, very creative, DEDC. And then I have 5 books here for questions, right?
Yeah.
All right, so opening up for questions, I'll leave the slide up. I have 5 copies. Dennis is going to answer questions. I know nothing. It's all Dennis. So yeah.